Alright, so this is the first example. As I said, what we're going to do is we're going to do the instance centers, the locations for these, the number of instance centers, and the links, that which is the first part. So real quick, we're going to do the steps to solving. So let me turn this up. 48 is fine. Actually, no, we're going to do 94. So step one should be know the number of links, right? And the reason why you need to know the number of links is because to know the number of links is to know the number of instance centers, right? So number of links is the first one. So how many are in this question? And I will go ahead and 3. Muhammad is correct. 3. We have the ground, this Revolut link, and this big circle. So 3 links. Step 2 is to find the number of instance centers. So for this one, it's probably really easy, but the equation, so number of instance centers. And for this one, the equation is n times n minus 1. You guys, it's in the chapter. I'm actually going to pull that up before I mess that up horribly. Oh, I already had it open. Never mind. Let's go find it. There it is. So it is n times n minus 1 over 2. So n times n minus 1 over 2. Right? So for this question, what is that? So we have 3 times 3 minus 1, which is 2, divided by 2, which is 3 instance centers, right? Yes, Jackson. Here, real quick, delete that first one. So it is 3 times 2 divided by 2. Just 3. So like I said, so real quick though, you probably won't get ones with 3 like this. I'm gonna be honest with you, you probably won't. I'm probably gonna give you ones that are 4 or 5. You'll probably not, because these are really easy. Like I just picked this one because this is a really easy example just to get us reminded about instance centers. So number 3. So now that we have the links, number of instance centers, we have to find all given ICs. So find all the given instance centers, and for this one, they're all given because they're all 3. It's only a 3-1. So essentially, they're all given. So that's another lesson, is that if you have a mechanism with only 3 links, the instance centers all have to be given, because think about how we would solve it. You couldn't use another triangle to pinpoint the other instance center because there's only one triangle. So if there is a 3 link mechanism, the instance centers are all known off the start, right? And then obviously, if it was more challenging, we would have 4. Find or use the circle diagram to find missing instance centers. So should. So right here. So real quick, we're going to be, like I said, we're going to use our. How can I zoom? There it is. So we're going to use our 2D shapes and everything to find all this, although something's wrong. Not working very well. I can't select that for some reason. This must be like locked up. There it is. Oh, I must have been locked on that, so let's see if I can get rid of this. Alright, cool. So, before we start, Yeah. That's step 5 is ASDAS. So what we're going to do is we're going to make the circle diagram. So I'm going to draw mine right here. Right? Big circle diagram. And then what we're going to do is we're going to have probably turn that down to 48, but 1, position that there. 2, now I can't move it, and 3. Alright, so that right there is our circle diagram for this question. And like I said, due to it only having 3 links, 3 instant centers, we do not have a third triangle or a second triangle. There's only one, right? So all of these must be known off of the beginning. It also falls under the link rules that we talked about beginning. Because if you remember, for any 3 links, there are 3 instant centers. And so we can pretty much solve this one right away. So I'm going to go ahead and get the line tool out for you, and you guys are going to tell me where every one of them is. So, although I'm going to use, where's this one looking like? Yeah, there it is. So, first off, tell me where, I'll use red. Tell me where I12 is. So I12, for the people who do not know, is this right here. We're connecting these 2 lines. But it is not the line here, it is on here. So where is I12? Where is it located? It is at the joint at the ground. Yes, so essentially it's right here. It's between 1 and link 2. So we are, let me turn the thickness up a little bit. So that right there is I12, and I will go ahead and add a text box to it. I12. So I12 is right there. Perfect. Now let's move on to I23, which is, we connect this over to here. I'm actually not going to do that one. I'm going to do a different color. I'd like to, at least. Anyway, whatever. We'll just do that. So, red. So, where is I23 located? Now, be careful here. So I will caution you here because there is something which I will pull up in a second. Where is it located? Right here. So if you recall, we have sliding, revolute, rolling contact, and roll slip, right? So what do we have in our problem? Remember this in front of us. What is our problem? Right here. I'm talking about 2 to 3 right now. Just 2 to 3, because we do have another one, I agree, but we're talking 2 to 3 right now. What is this right here? Which case of these is it? Perpendicular to the channel. Yes. So you are saying that our case is this right here. Is that correct? You would be right. So Let me go ahead and minimize that. So we are going to go ahead and write or put a dot right there, or not a dot, it has to be a line. So you are saying that it's like, we'll just say it's this right here, right? Is that what you're saying? It's plus or minus in that direction. I agree with you. Right. Alright, and then I13, the following. Oh, we're going to use green. How about that? Green. So, and the last one is green. So, which one, or how do we find the last one? While I put the text box up for this one. This is I23. At the surface, the bottom of the roller, correct. And the reason is because this is rolling contact. And you can see that because, think about it this way, if this lever pulls down here, it'll get to the end of the channel, and it'll start making this thing rotate like this, right? And then, as that thing goes the other way, it'll start to work its way over here, and it will continue to roll. This thing will roll a little bit, and then it'll come to the other side and start making it roll like that, right? And so, this is rolling contact, and therefore for rolling contact, you have the dot right there. That is I12 for our purposes. Or I31, that's my bad. I31 is right there at that location. So for this one, it's fairly straightforward, right? Fairly straightforward. You know, the reason I picked this one was just so you guys, because this one had rolling contact, revolute, and slider as well, right? Or a roll slip. So nice practice to get it all working, right? But now we're going to go into something a little more difficult. And you guys might be wondering, you're like, well, wait a minute, don't these things all have to exist on the same line, right? Because that's, or a line connecting 1, 2, and 2, 3 has to contain I31. Well, remember, this slider can be anywhere along this line. So if we move the slider to here, and you connected I12 and I23, you get it on this line, right? Is anybody confused by that? So if you put it like here, it went straight down essentially. Here, I'll move it. Something like that. If you moved this line and moved it down and you connected, because remember, a line containing, or I13 must be on the same line as I12 and I23. So if you take I12 and connect I23, you just draw a line straight down. So it does exist on that line. But it just didn't work out that way because of how I drew it. But what's funny is that as this thing moves further, it does essentially I31 just follows a line. Essentially I31 is always going to be right here. And I23 is going to move with it essentially. So as I23 starts to point straight downward, right? This thing will get further away from us, right? And then point straight down on top of it. So it does work out. Ooh, that is a big eraser. That is what I need to do though, but ready? So the next question, which I will copy and paste into here in a second, but I am going to leave that link up there, or that these right here. So Ooh, which one is it? I think it's this one. Yes, it is. So, right here. This is the harder version. The harder question. So we've seen, what's funny is you've seen all of these mechanisms, but they're just combined now, right? We now have that one that goes up a wall. We now have that push one we had before, and the little paddle thing here, right? Or the little, whatever I called it, the pinball slapper. Anybody know what those? John, since you're in here, what are those things called? Pinball what? I don't know if he's actually here.
I have no idea. Arms.
Yeah, pinball arms. Thank you. So, this is the question we're going to be doing. I'm going to zoom it in real quick so we can get that. So, the first thing that we have to do is follow the steps here. Number of links. So, how many links does this thing have? And yes, I know they're numbered. They will not be on the exam, I promise you. So, I'm well aware. So, how many links do we have? 6, that is correct. Let me go ahead and get rid of these other ones. I'm just going to draw next to it. So we have number of links. 6. And with that, what's the number of instant centers that we have? So remember, it's n times n minus 1 divided by 2. So anybody got the quick maths in their head? 15, correct. So, and now, real quick, remember what I said yesterday is that you do not have to find all 15 unless it asks specifically to you to find all instant centers. But if I gave you one with this many links, I would not expect you to find all of them. I would only expect you to find the ones that solve for H3 or H4 or whatever I asked for, right? So you will not have to do all of them. For something like this, now if I give you one that's like a 4 link one, I'll probably have you find all of them because that's only what, 6 or something like that. It's only 6 instant centers. That's not bad. All right, so since we've taken care of the first 2, we now have to find all given instant centers. So given instant centers. So let's draw the circle as usual. 2D shapes. Alright, and then I have to go ahead and number these. So I'm going to try this to be as neat as possible. 1. And then 2. That's going to annoy me, so I am going to change that. So real quick, before I move on, I'm going to get rid of that, because that's annoying. Alright, there it is. So, we now have our circle diagram, right? So this is our circle diagram that takes place right here. So now we have to find all the given instant centers. So the given instant centers. So let's start out with I12. Does anybody have any ideas where we might find I12? So link 2 is this yellow bar right here. That's your first hint. The ground is link 1, so this is a sliding contact. It is a prismatic pair, so that means what? Plus or minus infinity, correct. So I don't know where I'm going to draw that quite yet. I'll just put it right down the middle. How about that? Is that good for everybody? because we are going to have to change this. I do want to make that clear. We are going to have to move this to solve something, but I'm going to put it... actually, I'll put it out here. Because it can be anywhere on here. But I'll put it out here. Dude, why is this thing just flipping around? Anyway, whatever. We're going to put it... I'll just put it right here. Never mind. So, right here is... And I will text it as I 12 plus minus infinity. Right? Hopefully that's clear for you guys. That is what I 12 is. Plus or minus infinity. Somewhere on this... It's somewhere on this line that can be anywhere. It can go left or right here. But as you guys remember, we are going to eventually have to move that line, right? It'll have to, if we use it to solve for something else, we'll have to move it. So I12 we have found. What about I23? Anybody want to take a stab at that one? Where is I23? Remember, it is where the relative velocity of link 2 and link 3 is 0. So essentially they're moving at the same speed there. So where are both of them moving at the same speed? Where they are connected, right? So where are link 2 and 3 connected? At the slider, so right here, right? Is that what you're talking about? Yep. What in the hell is going on? Oh, it's the eraser. What am I doing? Let's do a little more than that. So right there is I12. So I'm going to draw a little line or something showing that one. Actually, never mind. We're not going to do that. I'll just do a text box next to it, a small text box. So this right here is, let's turn it down a bit. So I23. And what else is there? While we're here, right? What other one is there at that same space? What other instant center is there? Whoa, we just got a bunch of the completely different ones. So, I'm talking about at this exact same space right here. 3, 5. That is correct. It's 3, 5. So we have 2, 3, and also, Junlin, you are also correct. It is 2, 2, 5, 3, 5, and 2, 3 are all right here. It reminds me of that problem we did yesterday, where remember you had all of them coming to the same revolute joint. So yes, you are both correct. It's I 2, 5, 3, 5, and 2, 3. So I'm gonna write that all down. So I23, and I'll make that a little bigger. I23, I35, and I25. So let me move this a second. Alright, so that is all right here at this little line. There's not a really better way for me to do that, so I hope you guys can follow. So, now that we have that, let me go back to our circle diagram. So we now have 2, 3, so let me mark that down, 2, 3. We have 3, we do not have 3, 4, we did not do that. We have 3, 5. And we also have 2, 5. And that's not what we wanted. Right? So that's what we're working with so far. There are 2 joints, right? Where? You're talking. So right here, there's. So 2 is meeting with link 5, right? 3 is meeting with link 5, and 2 is meeting with link 3 here. We haven't gotten to 3-4 yet, which 3-4, as you guys can imagine, is also right here on this. We didn't. So whoever said 3-4, which Jackson did at the very beginning, we will get back to. We're about to do that one right now. So 3-4 then, because you said so, Jackson. Where is 3-4 at? So I will draw it. Dude, why does it do that every time? So 3-4 at the blue slider. That is correct. So he has said that it is right here. And he would be correct. So I'm going to go ahead and text that one. 3-4. So I-3-4 is right here, that little thing, which I will draw a line to. So I-3-4. Now let's go with I-4-5. Where is I-4-5 at? Can we find I-4-5 yet? How with what we have? Is it a given? How about that? That's the question I want to know. Is it a given one that we can find? From the very beginning, without using any other triangles, is it a given? Yeah, so that's another one. We're about to move to that. My question is 4-5, is this right here? Is this a given one in the question that you don't need to do any other solving for? Like all of these are given, right? Like 2, 3, 3, 5, 1, 2, 5, or I-2-5. These are all given. This is a given. We didn't need to solve anything. We can just look at it and know that's where it's at. Is this one between 4 and 5 a given one? So a good way to know this is that they are not touching in any way. 4 and 5 are not contacted in any way. Link 3 holds between them, but they are not contacted. So therefore, an instant center between these two is definitely not given. So we can leave that one blank for now, right? Leave it blank for now. Is there another instant center that has to do with this block over here? Four one. Jackson is correct. So 4-1 is, remember, the ground touching this block. It's the contact with the block. And so since you said that, Jackson, how does this one look? What does that instant center look like? Plus or minus infinity, correct. So this one is plus or minus infinity. Once again, I'm just going to draw this somewhere, but remember, it can be anywhere up or down, right? So I'll just draw it right here. And let me go ahead and I-4-1. So the reason, no. So remember, it's always perpendicular to the line of translation. So remember, this one is going left to right, which means this one must be going up and down. For this one, it's going up and down, so it has to go left to right. You see? But it can go infinity it can pull it any direction this way. Like for this one, you can pull it up or down. So this line could be down here, or it could be up here, but it has to be perpendicular to the line of action, to the line of translation. Does that make sense? Yeah. Alright, cool. So that one is also known. And like I said, guys, a bunch of these will be known from the beginning. From the very start, you'll be able to find a lot of these just by looking at it. And I think Junlin mentioned one just a second ago. He mentioned I-16, right? So I-16, since you said that, Junlin, where is I-16 at? At the ground and link 6, right? So this pinball thing and link 6, which is right here. So right there. So I will go ahead and text that one. Or I'll do I61. Probably better. So I61, we have, let me go ahead and write that one out with a, or line that one. So, right there. So we now have I61. Is there any more that we have? So, Muhammad, you are correct. That is the one I was just getting ready to talk about. So we have I6 or I56, which is between this block and this slider. So what would we do about this one? Remember, it is a sliding contact once again, so how does this one look? Where would it go? Anybody? How would we do I56? Which is right here. Plus or minus infinity again, that is correct. And once again, it's just going to go in whatever direction I decide to put it in. Like right here. I think I'm going to drop it right here. But remember, it can be this way or this way. Like, it doesn't... But I'm going to write this one. So it's I56 plus minus infinite. And I don't think I did that for the other one. Yeah, I forgot to do it for I41. This one is plus minus infinite. So, alright. Now that we have, I think we have completed every single one that we had to start with. I'm pretty sure we have, that is the start of it. So, now what I'm going to do is, now that you, so everyone kind of keep track of these in your mind. I kind of want to do a blank diagram, which I think I'm going to do because this actually gets really bad. This one gets really, really bad. So we're going to try and change the pixel, or the canvas height. So what I'm going to do is I'm going to add this same picture back again, but I'm going to put it down here. And we're going to solve, we're going to keep them where they're at so you guys can see it, and then I'm going to solve a blank one because that would have been really annoying. Alright. Yeah, we'll do it over here. That probably makes the most sense. Alright. So, right here is going to be where we solve these. So, how would we start this? So, what ones do you got? So, let's try and find some, maybe, let's just go around the horn here. Go around the circle. So, which one that I'm going to think we should solve for first is, let's do I13. So I13, let me go ahead and do that. So I'm going to make this a different color just to simplify. But I13, we're going to start with red. Oh no. So I13 is the one we're going to be looking for. So we need to make 2 triangles containing I13. So, anybody want to take a shot at this one? So what we would do here is that we need to create we need to basically put these lines together. We have a lot of infinite lines here, right? The plus or minus infinities, we have a lot of those. So what we're going to do is we are going to do first one, which is the first pair of I12 and I23. Yeah, so I12, I23, which is this pair, and it contains this line. So if you recall, I12 is this straight up and down line, and I23 is right here at this pin. So what we're going to do is we're going to take I12 and move it to that pin. So it should look like that. That's the first line of that's our first pair. Now we need to find the second pair. The second pair can be probably a couple of things, but whichever one you guys want to use. Actually, I think there's only one possible right now, which is 1-4 and 3-4. Yes, so gentlemen is correct. So 1-4 and 3-4. So 1-4, if you recall, is this infinite line here. And 3-4 is right here, this pin, this line right here. So what we're going to do is we're going to do the same thing we did before. You're going to take this infinite line and you're going to move it to the pin. I did not get that one right. Very straight. And that's fair enough. So these things have crossed. So where is I31? So real quick, I31 is directly at that intersection right there. Because that is where they have crossed, so right there is where we have found it. Is everybody good with that? Once again, this will be on the video. What I'm going to do is I'm going to erase this and then do the next one. The problem is, I guess I could add it up here. But the problem is that if you keep this on here very long, it starts to get really messy, and then we're crossing a bunch of lines, and I don't know. Do you guys mind if I just cross a bunch of lines, or you would rather not? Rather not. Okay, so it'll be in the video. If you guys need to go back and look at it, that is fine. So what I'm going to do is I'm going to erase this so everybody kind of knows why that was there, hopefully. Actually, I'll just... Oh, I can't go back that far for some reason. Yikes. Am I going to have to insert a new picture every time? It looks like it. That is dumb. Because I could not go backwards on redo very often. Alright, so now, as I said, now we gotta do the next one. So we found I13, right? Using that combination of points. I13 was located here and here, so it's kind of like right in this area. So, I mean, I could just write it there. It was basically right here. So that is I31. Yeah, it was basically right here. So I31 was, let's do that, right there. So I31 right there in that area. Now let's pick another one and a new color to go with it. So the new color, I don't know, which one do you guys want to find? Could do 3, 6 maybe. I'm trying to think if we could actually find it or not. Yeah, you could do 3, 6. Oh, 5, 1. Okay, so 5, 1 it is. So 5, 1 is here, and I will change that to, we'll do purple for now. So 5, 1 is the one we are looking for. And you are suggesting what? That we use 6, 1 and 5, 6, I assume? As our first pair? Correct. So we are going to do that. So let me go ahead and grab this. And so, remember, since this is another plus or minus infinity line, we can drag it anywhere. But where we choose to drag it is to the other point. So the other one we're using. So we have 1, 6 and 5, 6. 5, 6 is the infinite line. We need to pull it to 6, 1. And so 6, 1 is right here. So I'm going to draw the line slicing right through the middle there. So that right there is our first pair. Our first pair slices right through 6, 1 and goes up and down here. Now, our next one is what? Are you going to use 1, 3 and 3, 5? Sorry, go ahead. One, 3, and 3, 5. Got it. So, 1, 3 is the one we just found, by the way. So I will have to write that back on here. So what I'm going to do is I am going to draw 1, 3 again. If only I wasn't terrible at it. Oh my god. It's a travesty. Alright, so 1, 3 is right there. And it is on another line right here. So 1, 3 is at the connection between these two lines. So right here, thereabouts, right? So I'm going to drop this dot right here. So 1, 3 is right there at that dot. So 1, 3 and 3, 5. So that means we have to draw a line from 1, 3 to 3, 5. So what does a line from 1, 3 to 3, 5 look like? This one worked out fairly well. What does that line look like to go from I13 to I35? I'm slowly erasing it away so you know, so I've given you the answer. Does it happen to look like a horizontal line straight down? Or a vertical line straight down? So I35, remember I31 is right here. It is this dot. I35 is this connection right here. This point, remember we have it right here. So I35 is right there. So it is a straight line straight down, right? We have to connect those two. Does that make sense? Yes, now. Okay, cool. Alright, and so if we connect those lines are out in one direction versus another, you will find that it should end up at that connection. And that should be I. Which one were we looking for? This one was what? 5, 1. So I51 should be right there. And I will go ahead and write that one in our problem. I'll put a dot there, but it'll probably be a little bit off of where it's supposed to be. But I51 looks like it's going to be right here. Oh no. Alright. 5-1. It is right there. So I51 is that dot. Now let me go ahead and do the magic eraser. What we're going to do is we're only going to find probably 2 more of these, and then we'll call it, because obviously we don't need to find all of them for remember, because this type of question I would only have you find the ones that involve like link 3 or 4 or whichever one I give you. So while we do that, let's find all of those, which I think we actually have already. I think they're already all found, but I am fairly certain they are. But alright, so new blank canvas. We have found that one. So what's another one we can find? There's not many more choices left. There's, what, 2, 4? So here, I'll write these out, because I actually am. So I24 is one of them. What's another one? I63. I62. I64. I45. Okay, there was more than I thought. So 6-2, 6-3, 6 errors. So 6-2, 6-3, 6-4. 5 is to all of them except for that one. 1 goes to all of them that we have. 2. Yeah, I think this is it, right? If you find another one, just let me know if I'm wrong. But I think this is it. So let's find one more of these, and then we can call it if you like. I will finish the problem on the video probably, though. I'll finish it. But you remember, we don't need to solve all of them, because the ones that we need are the ones, although, actually, let's solve for I24, because I24 is one that you would need. So we're going to do I24, because remember, for that equation, for H sub 4, you would need I12, I2, is it I24? Yeah, it's I24 over I14, I24. And we don't have 2-4 yet. So let's do 2-4. So if I ask you to find the kinematic coefficient, you do not need to find all of them. You just need to find the ones that get you the kinematic coefficient, which is what I just showed you. So, now that we know that that's what we're solving for, I'm going to go ahead and put a line there. And I will change the color to, let's do blue. So blue. So, now that we have, that is our goal, how are we going to proceed? How can we do this one? And just to let you know, the solution manual doesn't even find all of them. They actually stop. They stopped a while ago. They only found the ones you needed to do the kinematic coefficients. So we're just finding ones just to get you some practice. So how do we do this one? 2, 3, and 3, 4. I agree with you. So what he did was he found these two pairs. So he did 2, 3, or this pair, 2, 3, and 3, 4. So where is 2, 3 located, and where is 3, 4 located? We've already used this one, I think, for something else. So 2, 3 is located here at this one, right? And 3, 4 is located here at this one. So they're remember, we have to pull. Now this is where it gets interesting because we now had to pull this one over to that right here. If you recall, remember we did that for the other ones. You take this plus or minus infinity and you move it to where they're connected, right? So this is the trick. So wait, 2, 3. Oh no! Wait a minute. I made that mistake. I read the wrong one. My fault. So get rid of this actually. So 2, 3 is here and 3, 4 is here. That is my fault. I thought it was. I thought we were doing 1, 2 again. So if 2, 3 is here and 3, 4 is here, you draw a line connecting straight through the middle of those two. Which is that. That is our first pair. Now we need to find the second pair. So any ideas of where the second pair is coming from? You're in the home stretch, guys. Looking up and down this chat, there's a lot of Jackson. Maybe we could get someone else in here. Not you, John. So, Sean, would you like to answer? Or not really? If anyone is still alive out there. I think they're all gone. So, real quick, we did 2, 3, and 3, 4. We need to now find the other we need to find the other 2 that we're using. Is there a line at link 2? Ooh, what do you mean? Through the link. Like a straight line? So yeah, it is a slider. It's an up and down one. But remember, what I did was I messed up. If I confused you, I messed up at first. I thought that we were doing 2, 1, which is an up and down, but it's not. It was actually 2, 3, which is here, and 3, 4, which is here. So I messed up at first by having an up and down line. And Rosendo said 4, 1 and 4, 2. So he did the other side of the triangle, which is 4, 1, which is here, going to here, and 4, 2. 4, 1 and 1, 2, you mean, right? So 4, 1 and 1, 2, and then 2, 4 shares the same line, which is what we're finding. Yeah. So that is good. I like that. So let's do 4, 1. So 4, 1 is located as a straight line, it's plus or minus infinity. It's a slider, right? And 1, 2 is located where? So 1, 2 is also located on a slider as well, or a plus or minus infinity. So it is somewhere along here as well. So this is one that doesn't show up very often, like where you have 2 plus or minus infinities running into each other. So essentially what this means is that I 2, 4 will be on this line. It only depends on where you put your other in plus or minus infinities. Essentially, it'll be on this line though. So, we could just do this. Like for example, if we put this line out here, and then let's say we did one right here, which is our slider line. Right? At least I think, one sec, let me back that up. It's going to be on this line though, so essentially it has to be at a place where those two lines meet, which I assume what you're supposed to do is you're supposed to move that line on the side. Ooh, why can't I do this right? God, I suck. So you're supposed to move one of these lines. So this line goes out to here, and this line goes to meet it on this link. And the reason why it is on that line is because it has to be, right? Because remember, at an intersection between 1 and 2 and 4 and 1, 2, 4 must be on that line, right? At the same time, 2 and 3 and 3 and 4 must contain I24. So a straight line, which was, remember, 2 and 4, or 2, 3 and 3, 4 was this straight line down here. And since these other two lines are infinite lines, it has to exist at an intersection between, basically between those as well. And so to get that to work out, you have to move this line down to this level and then connect it with this. So essentially I24 will exist at some level on this line, depending on where this slider is. So think about it this way, right? If we move the slider up, let's say the slider goes up here, right? Depending on where the slider is at, 2, 4 will exist at a different point in time on this straight line, depending on where it is at. So once again, I'm just going to draw it on the line. Essentially, it is on here where I put this red dot. It is there, but it can also be here or here or here or here, depending on where we are at in the motion. So this one is one of those logic ones. So this is a good learning case. Is that this one is not something that shows up very often. Actually, this is the first time I've actually seen it, because I didn't do this question last time. But you have to logic it out, and what that means is that because you know that I23 and I34 contain I24, it is a line connecting this point to this point, right? And since you know that I24 must exist on that line somewhere. Somewhere on that line it exists. Because the other two that we used to connect it were both infinite lines, which are these plus or minus infinity lines, you have to get it to a point. You have to basically take one of them and pull it down to get it to where it ends up on that line. Because, for example, what I did at the first part of this, what I did in the first part is that I drew it up here. And this was the logic in real time. So I drew it up here, right? And I said, oh, okay, well, then that's the infinite line, right? And this is the infinite line, right? Do you see a problem with this? The problem with this is that this I14 or I12 and I14, I drew it correctly. This is where it is. This could be how it's drawn. The problem is that this line doesn't contain this point, right? So essentially, this point right here, we want this point to be on this line because that pinpoints I24. But it wasn't on that line because of how I drew it, right? It's the same way we've been pinpointing all the other points, except for here, you can move them up and down depending on where you want them, right? We need that point to be on this other line because that is how we pinpoint it. And right now, how I've drawn it, this is not a correct statement because I24 is not on, I24 must be contained on a line containing 3, 4, and 2, 3. And right now it is not. Right now I've drawn it up here, and this dot isn't connected to where it needs to be. It needs to be down further. It needs to be on this line to make the statement true. That one I just did. I don't know where redo is though. But it has to be here. But however far you draw it, doesn't matter. So for example, you could have put the up and down arrow, like you could have done it over here. And then you could have, drawn it like this. And at that connection is where it is. It doesn't matter as long as it's on that line. That's where we need it to be, is on that line. but I would say that you will probably not run into something like this. This is actually a very difficult example. There's a lot of sliders, as you guys saw. So this is a rather difficult example. But for most examples, you won't see something like this. Alright, so is everybody good? Because I'm going to stop the recording, and then we are going to take attendance, and you guys are free to enjoy your 4th of July weekend.